In this video, I'm going to show you how we can use this spreadsheet to help us compute a nearest neighbor circuit without doing a lot of the arithmetic yourself. So I've got an image here of the graph that I'm going to be building. So these are the vertices of my complete graph that I've just put in front of the spreadsheet so we can visualize it. Additionally, here I have all the data of the time in minutes between these restaurants that I've decided to visit. The blacked out lines down the diagonal are the fact that there's no distance from the pizza place to the pizza place, for instance, and so on. So to begin, we'll do a nearest neighbor circuit. I already ran a cheapest link. So I'm going to pick an arbitrary vertex to start with. So let's find the nearest neighbor circuit that starts and ends at the Thai restaurant. Remember, you'll run this for each of the vertices as a starting and end. So I'm going to focus on the Thai restaurant column as my place to start. So we're going to focus on that column. And I'm going to look at which of the lengths in this column is the smallest. And I notice the closest restaurant to the Thai place is the barbecue restaurant. So I'm going to draw an edge from Thai to the barbecue place. And then I'm going to, under this is nearest neighbor, I write it in equals. And then I'm going to click the length of that edge that I wanted to use. So now I'm located at the barbecue restaurant. The easiest way to continue to follow the nearest neighbor is to use the row for this vertex I've landed in. And again, I'm going to choose the shortest length I see, which would be the length from the barbecue restaurant to the pizza place. So I'm going to write plus and then click on that particular cell so that I've locked that in. And now I'm going to come over in my graph and I'm going to indicate that. So I went from the barbecue place to the pizza place. Then next, now I've landed in the pizza places column, so I'm going to follow the pizza place information. Look at the shortest length I see here. The shortest length is to the Thai restaurant. However, if I were to draw an edge over in my graph from the pizza place to the Thai restaurant, I'd close off a circuit too soon, which I can't do. So I'm going to not take that edge. Instead, I'll look at the next shortest length. So rather than the 12, there's a 13 to the oyster house. So the next thing I'll do in my formula is I'll add the value of the cell going to the oyster house. And I will come over and draw that edge in so we can see it from the pizza place to the oyster house. Next, I'm now looking in this oyster house row because that was the 13. That's where I landed, was in the B13. So I'm in the oyster house row and I look for another short length. Looks like the closest place to the oyster house is the cafe. So I click on the cafe, that's the C9. So I've C6, so I've added that of length 9. Oyster house to cafe, drawing that edge in my complete graph. So now I'm in the cafe column, and I'm going to look for another short edge. The Indian restaurant hasn't been visited, and that's a length of 10. So in the formula for this cell, I'm going to add the 10. So if you notice as we're building this formula, you can read it right here. Notice it was D7, B7, so two things that were in the same row. Then it was B7, B6, two things in the same column. B6, C6, two things in the same row. C6, C5, two things in the same column. That's that entering and exiting each vertex that's getting utilized there. To return to where we were in our process, we're currently at the cafe. We need to find a length from the cafe. So we find ourselves in the cafe row, I believe. Is that right? C5. No. C6 was cafe to oyster house. Oh, C5 is to the Indian restaurant, which I have not yet drawn. So let me draw that. Sorry about that. Indian to the cafe. And it looks like at this point, actually, I've just got left to visit the vegan restaurant. It's the only place I haven't been. So once I'm at the Indian restaurant, now I'm going to go to the vegan place, which would send me over very close distance. Actually, it's just this length of 3 here. H5. And then finally, I'll have to return to the Thai restaurant. So from the Oyster House, I'm going to go to the Thai place. From the vegan restaurant, I'm going to go to the Thai place, which is not short. It's 25. So now I'm going to hit enter. We can go back and click on the formula and see that we have the right thing. So notice we have 1, 2, 3, 4, 5, 6, 7, 8 links is too many because I accidentally added in C5 twice. There we go. So I should have 7 links because in my example I had 7 vertices in my circuit. This is the circuit it represents. And I can go triple check that those are the links that I added. D7 is barbecue to Thai. Then B7 is barbecue to pizza. I drew my art wrong when I drew that. Did you see that? It should have been this one. Indian, vegan, Thai. There we go. And so on and so forth. So I hope that helps a little in how you can use this process to get the lengths. And so this nearest neighbor circuit was 79, and then I could continue to do that for each one. And I've just left it in that particular column to help me out. And so then I can go through and leave the artwork for this particular picture. I recommend, because these are locations in the real world, that you actually lay them out on a map to see the edges as opposed to arbitrarily. This is not the order that these restaurants are in proximity. But now that I've got that circuit, then I could go and draw the next few circuits, and it can help to have the images of each of these circuits available so I don't duplicate anything, or I notice when I have.